Hello students, before going to solve the numericals based on equations of motion, we should note some important points, and these points are: number one, first, if the body starts moving from rest, if the body starts moving from the rest, then initial velocity u is equal to 0. Second, if brakes are applied, and the body finally comes to rest, then final velocity v is equal to 0. If brakes are applied, then the body will ultimately come to rest. The velocity will goes on decreasing, and finally it will come to rest. So the final velocity will be 0. And in this case, when brakes are applied, the acceleration A will be negative, and the negative acceleration are known as retardation. So first equation was v is equal to u plus at. Second equation, s is equal to ut plus half at square. Third equation, v square is equal to u square plus 2as. Here acceleration is positive, the velocity of the body is increasing, so we have taken positive here. But if brakes are applied, then velocity will go on decreasing. In that case, acceleration A will be negative. So the equations will be, in place of plus, here will be we will take minus. So third point, when brakes are applied, the acceleration in short we will ACC, and acceleration will be negative. Negative acceleration, and negative acceleration is known as retardation. And in this case, when the acceleration is negative, the equations will be here. The equations of motion will become first equation, v is equal to u minus at. Second equation, s is equal to ut minus half at square. Third equation, v square is equal to u square minus 2as. So we have taken negative sign in case of when brakes are applied, acceleration becomes negative. Clear? And if the body is moving under gravity, whether the body is going up or down, so in place of A, we will use acceleration due to gravity. Acceleration due to gravity is denoted by small g. If the body is falling, that is, it is coming downward. So the acceleration due to gravity g will be positive. In place of a, you will write plus g. So what will be the equation? Motion under gravity. What will be the type of the equation when it is moving downward under gravity? Motion of the body under gravity. Motion of a body in downward direction. Yeah, under gravity. Under gravity. Under gravity. What will be? In place of g, the acceleration will be g. Acceleration due to gravity. First equation, when motion of a body under gravity in downward direction. In downward direction. जब वो नीचे आ रही है तब. First equation, v is equal to u plus gt. Acceleration due to gravity g. Second equation, height. In place of h, we will use height. Height h is equal to ut plus half gt square. And third equation is v square is equal to u square plus 2gh. In place of s, we will take height h. And this is the motion downward direction. If suppose the body is thrown upward, the body is going up, the body is moving up, but the acceleration is acting. Acceleration due to gravity always acting downward. So here, body is going upward and acceleration due to gravity is acting downward. So the sign here will be negative. So number next. Number, this was 4. Number 5. Motion under gravity in downward direction. Motion under gravity in upward direction. Motion under gravity in upward direction. Upward direction. Here g will be negative. First equation, v is equal to u minus gt. Second equation, h is equal to ut minus half g t square. And third, v square is equal to u square minus 2gh. So this is the form of the equation of motion when the body is moving upward direction. Next point, suppose a body is thrown upward. So you will give some initial velocity, then the body will go up. It will go up, 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 and at the highest point, its velocity will become 0. Why? Because acceleration due to gravity is acting downward. So its velocity will go on decreasing. You have thrown a stone. You have given some initial velocity, but the acceleration due to gravity is opposing it. So its velocity will go on decreasing, 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 and at the highest point, its final velocity v will become 0. Then the body will return back. So you can write this next point as when the body is thrown upward. Point number 6. When the body is thrown upward, then at the highest point, the final velocity. Final velocity v is equal to 0. Number 7. If suppose a body is dropped, just released, you have given no initial velocity, you have just released the body. Try to understand the difference. The body is thrown. The body is thrown means you are giving some velocity, some initial velocity, but if you have just released the body, it means the initial velocity of the body is 0. If the body is dropped, so in the numericals, you should try to understand these points, that whether the body is thrown or body is dropped. If the body is thrown, then initial velocity will not be 0. If it is dropped, then we will take initial velocity u is equal to 0. The next point, if the body is dropped, then initial velocity u is equal to 0. And when it is thrown, then it will not be 0. So remember these points before going to solve the numericals. If you have these points in your mind, then you can easily solve the numericals. We will solve numericals in the next video. Till then, bye bye.